Welcome. Let's look at using graphing to solve linear equations. All right, so we're going to focus first on the different parent functions. And the parent functions are the basic line, like y equals x is the diagonal line that goes through through the origin. And every other linear equation is similar to this, but it's moved sideways, up and down, twisted in some form. The other ones we have are things like y equals x squared, which is always a parabola shape. Y equals x cubed, which is always some type of S shape like that, adjusted, of course, with other numbers in it, but that's the basic idea. An absolute value, which is always going to be some kind of V shape. A square root, which is always going to look like this. Not quite straight, always curving, but very little. And then we will at some point deal soon with exponential functions, and those are ones that look like this on a graph. Okay, so we'll get to all of those, but right now we're first going to we're going to work with linear equations right now, straight lines. This part here is to make sure everyone recognizes that these four things essentially means the same thing. They're often just different ways of writing it. Like the roots like this are when the two answers are still in parentheses form, because if you multiply them together, you can get back to the original, like sort of like roots making up a big tree. Now, solutions is meant one more step than doing this, saying then that separating them, x minus 3 is equal to 0, x is equal to 3, and also x is equal to 5. So you can find the solution by saying x equals. That's what that does. Zeros are the things that, the numbers that would make it 0. If you put the number in there, like this one here, if you put a 3 in there, you're going to get a 0. So 3 is going to be 0 for it. And then if you put a 5 here, you'll get another one. A 5 would make it 5 minus 5, and 0 times anything is 0. So those are zeros. And the x-intercepts are perhaps the easiest thing because you have done those before. It's simply the place where it hits the x-axis. So let's use these numbers here to determine about what a quadratic might look, and using these terms or thinking about them. So first, if I'm going to make them into roots here, I'm going to take the opposite sign. And the reason we do that is that let's take something like x plus 5 is equal to 0. If I want to know what x is, I subtract that to the other side. So x is negative 5, and that would be why it's a negative 5 here, because it has to be moved to the other side of the equal sign. Erase that for now. So if that's so, then the x's for this are the opposite signs of each of these, negative 5, 2, and 4. And so let's go ahead and graph those. 1, 2, 3, 4, 5, 2, negative 5, 2, and 4. So what happens here, once you have those in there, oh, and what I put here was actually what I meant to put down here before. So I'll do that now. So it hits 3 places. That means it's an x cubed. We don't know enough other detail, put the other numbers around it, but it does mean that it's going up like this, coming down and up again. Now let's move on from there. Now let's solve by graphing here. You can solve these in a number of ways. Elimination and substitution are good ways, except it specifically says to do it by graphing. So one thing to recognize is that although it's possible right now to work this out, and I'll do that first, it actually ends up confusing things. So this becomes 4x equals negative 8, so x is equal to negative 2. What we need is the y value with that. So if you put the 2, that negative 2 back into these places, one of them, you'll find that it'll Well, let's see what happens. If I put -2 in there, I get -10 plus 13, or plus 3 is 13. And does it work? Oh, no, it's not 13 because it's plus. So 5 times -2 is -10, plus 3 is -7. On the other one, -2 minus 5 is also -7. And that means then that the point of this, the point where these two lines meet should be -2 and -7. Well, that was one thing. These aren't two lines. This is one equation. Actually, it is, if you separate these are two lines. So let's do that. Let's separate them. Y equals 5x plus 3 and y equals x minus 5. Now we graph these by taking the y-intercept and then using the slope, 5 over 1. So let's do that first here. Go to a positive 3 and a slope of 5 over 1. Okay. Oh, that's it. So 1, 2, 3, 4, 5, and over 1, 1, 2, 3, 4, 5, and 1. And see if I can get that reasonable there. I think that's reasonable. Now the other one, let's do this one. We're going to go to -5, and that one I'll put in black. 4, 5, -5. And the slope here is 1. So that's like 1 over 1. That means 1 up, 1 over, 1 up, 1 over, 1 up, 1 over. It's this kind of a thing. Oops, made a mistake with that one. Hold on. So it looks like these meet. Whoops, let's bring that one back down. So they're going to meet somewhere down about here. -2 and -7 is about here. And although my drawing's very poor, their lines are sort of close to that. Okay, so you can see that it's supposed to be there, which is -2, -7. Let's do this next one, and for this one, I am simply going to immediately separate them as two separate equations. On this one, I see the x terms in the wrong place, so I'm going to move it in front. Now I have the intercepts, 8 first, and a slope of 2, which can also be written as -2 over -1, so I can come down and over this way. Well, I'm just going to hand draw it this time. And on the other one, we're going to go to +3. We're going to go up 2 and over 1, up 2 and over 1, up 2 over 1. It looks like we have a problem. These two lines are parallel, so they never meet. If they never meet, that means there's no solution, because the solution requires that they meet. The solution is parallel. Okay. Get that yellow man. Very good. Okay. Now let's look at an application problem. This has to do with hair straightening. Using chemicals to straighten hair will make curly hair straight and smooth. There's a process that has to be completed, and the percent that's left to complete as time continues, there's less to do. This is the equation for it. Okay. T means the amount of time that is left for the solution to sit on the hair, and P is the percent of the process left to complete. Okay, so what we're going to do is solve, or rather graph that line. Okay, and let's figure out what we have here. So we need to do an XY table. So the T is actually what we would call X. And then the P is what we would actually call Y. So we have P equals 12.5. Oops, it's a negative. Negative 12.5 T plus 100. Okay. So let's think about how long. This is a clue. 100 is when it's also mostly done. At negative 12.5, that means we wouldn't multiply that by 10 times or 10 minutes because that would be too much. Well, I think 8 is going to be the number we'll use. So, and actually, let's actually be different here. Let's figure out. Let's set up over here the graph. Okay. So time is always, almost always, so much so that you can consider it always on the bottom on a graph. Okay, and it's in minutes. That means the other one here is process left to go. Okay, and that's by a percent. So that one's easy because it's 10, 20, 30, 40, 50, 60, 70, 80, 90. So the time, if I figure out, look at it this, it's going to take me 8, 10 minutes or so. I want my numbers to match that. 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, 7, 8, 9, 10 minutes. So let's look actually at the intercept. So somewhere along the y-axis is the starting point, right? And that means for that, x is equal to 0. So if I put the x equals 0, okay, I'll put that first this time, and I put 0 into here, that means I have 100. So when the time is just starting, none of the process has been completed yet. So it's 0 time and 100% of the process left to go. Now, let's put a couple of numbers here. I'm going to put in 1 and 2, and then let's go down then to 7 and 8. All right, so if I put 1 in here, I've already figured that out. If I put 1, we subtract 12.5 from 100, which is an 87.5. Now I wish I could do that, but it's more difficult from far away and from home and everything. Let's though now put this 1 in here. Oh no, I already did the 1. The 2 would leave 75% left to go. Let's come down to the 7. This would have 12.5 left to go, and with 8 seconds, there would be 0 left to go. So I can graph here for 100, that one. I'll put the 100 back over here. So that's 0 and 100, and this is 8 and 0. And I can put some of the other numbers, but instead, with those two being intercepts, I can now put a graph for that line. I don't like that one. Okay, a little bit better, but not quite, I want to say. I am trying very hard to be careful not to go outside of the boundaries, for the scenarios. Now, this is saying, okay, if we go to say 10 minutes, that means it was here where 60% of the profit was left to go. Or if I go to 6 minutes, that means there was just about 20 minutes left to go. Maybe a little bit more, but I'm thinking about 20, not 20 minutes, 20% left to go. So it had completed 80% of the process by 6 minutes. So let's look at what this says. Find a 0 of the function. Okay, so the zeros would be where it hits the x-axis, and we did that here. Okay, it's 8, 0. Explain what the 0 means in this context. That means in 8 minutes, the process is finished. Oh, so that would be the explaining what the zero is. Now the domain and range. So the domain is all the x's that are used, which is 1 to x, and the range is all the y's being used, 0 to 100. So a way we would do that is we'd say for the domain, it's all the numbers between 0 and 8. We put 0 and 8 on the sides, x in the middle, and that means we then apply these. So x is greater than one of them and less than the other. And we can put the make them equal sandals as well. So that's the domain. The domain stretches from 0 to 8, not beyond and not before. The other one then is the range. So, oops, I should do it like this so that the D is separate on there. Oops, that's the one I need. The range now, the range of the Y values, which go from 0 to 100. 0 is less than or equal to Y is less than or equal to 100. Okay, so that's the fourth thing, is the domain and range. All right, and now you've seen this scenario where, again, in this case, using the intercepts, let's get a line, and you could go further with it, but we're not doing that necessarily yet. Thank you for listening and watching. I hope this was helpful.